Hi, welcome to the lecture on D-separation.
The types of questions we're going to answer are of the following form. Are two random variables, x and y, conditionally independent given some evidence variable z? The answer will be yes if x and y are separated by z. To find out whether this is the case or not, we will consider all undirected paths from x to y, and if none of these paths are active, we declare independence. A path is active if each triple along the path is active. Let's start categorizing triples then. There are active triples and inactive triples. The first triple we'll consider is the causal chain, where a random variable A is pointing to random variable B to random variable C in the base net. If B is unobserved, as we see on the left here, we have an active triple. If the middle node is observed in the causal chain, we have an inactive triple. The next one we consider is the common cause, where we have a variable B which points to both A and C. In this case also, if the middle node is unobserved, we have an active triple. If the middle node is observed, we have an inactive triple. Now let's consider a V structure, or a common effect. Here the middle node B is pointed to by both A and C. Here we have a slightly different story. If the middle node is observed, we have an active triple. If any of the descendants of the middle node are observed, we also have an active triple. If the middle node is not observed and none of its descendants are observed, we have an inactive triple. A single inactive triple will block a path and make it inactive. Let's put together our entire D-separation algorithm here. D-separation proceeds by first being given a query. In this case, the query will be, is xi independent of xj given some evidence variables xk1 through xkn? What's happened first on is to shade the evidence variables. Then we check all, this is important, all undirected paths between xi and xj. We check whether, for each of these paths, whether the path is active. If active, we can right away return. And what we can return is the following statement. It's not guaranteed that xi is conditionally independent of xj given the evidence variables. If we work through all paths and we don't return, meaning we did not find a single active path, we get to the next stage here, and that means all paths have been shown to be inactive. If all paths have been shown to be inactive, we can return the guarantee that xi is independent of xj given the evidence variables xk1 through xkn. Let's look at some examples here. First exercise. We're asked to check whether v is independent of z with no evidence. Z is over here, v is over here. There is one path connecting v and z. This one path consists of just one triple. This one triple is a causal chain. A causal chain with the middle node unobserved. That means the triple is active. We have a path with just one triple. The one triple is active, which means all triples along the path are active. This means the path is active. Once we have found an active path, we know that just based on the graph structure, we cannot guarantee the independence. So v independent of c is not guaranteed to be true. Here's a second example. We're asked to verify the conditional independence of v and z given t. Z is here, v is over here, t is over here, is observed. There's just one path connecting v and z. This one path is a causal chain. The causal chain has the middle node observed. This means that triple is inactive. Once we find an inactive triple along a path, we know the entire path is inactive. In this case, there's only one path between v and z, so we have just found that all paths between v and z are inactive. When all paths are inactive, we have that the independence is guaranteed to be true. Now we're asked about the independence of u and v. U is sitting over here, v over here. There is two paths between u and v. Let's look at the short path first. UWV. This path consists of just a single triple. This single triple is a V structure. The V structure has the middle node unobserved. We look now at the descendants of the middle node. There's just one descendant, Y. That descendant is also unobserved. That means the V structure here is inactive. Once we find an inactive triple along a path, the path is inactive. So this path here, UWV, is inactive. Let's look. Once we find an inactive path, doesn't mean we're done. We need to keep checking till we either find an active path or we have found that all paths are inactive. So let's move on to the second path. The second path has several triples along it. Let's start with the first one here, UWY. This triple is a causal chain. This causal chain has the middle node unobserved, which means the causal chain here is active. The next triple here, WYX, is a V structure. The middle node is unobserved. We check its descendants. There are no descendants, so none of the descendants are observed. This means this V structure is inactive. Once we find an inactive triple along a path, we know the entire path is inactive, so we've now also shown that path 2 is inactive. Path 1 and 2 are the only two paths connecting U and V, so we have found that all paths connecting U and V are inactive. This means we are guaranteed that U and V are independent. We're again asked about U and V, and now W is observed. The same two paths are still in the graph connecting U and V. Let's again first check the shorter path. The shorter path consists of just one triple, which is a V structure. The V structure has the middle node W observed. This means this V structure is active. The V structure is the only triple along the path. This means the entire path is active. Once we find the active path, we know we're done. We now know that just based on the graph structure, we cannot guarantee the independence. We're again asked about U and V, and now X is observed. Let's first again consider the UWV path. That path consists of one triple. The one triple is a V structure. The middle node is unobserved. We look at its descendants. There's just one descendant, Y. Y is unobserved. This means this V structure is inactive. Once we find an inactive triple along a path, the path is inactive, so this entire path is inactive. Let's look at the second path here. It has several triples along the way. There's the UWY triple. That's a causal chain. Middle node unobserved. That means this triple is active. The next triple is WYX. The middle node, Y, is unobserved. Let's look at its descendants. No descendants, so we have a V structure here with a middle node unobserved. None of its descendants observed, so this V structure is inactive. Once we find an inactive triple along a path, the entire path is inactive, so we have established that both paths connecting U and V are inactive. This means we are guaranteed that U and V are conditionally independent given X. Again, we're asked about U and V, and now Y is observed. Let's check the first path, UWV. This path consists of just one triple. It's a V structure. The middle node is unobserved. Let's check its descendants. Its descendant Y is observed. So we have an active V structure. This V structure is the only triple along this path. This means the entire path is active. Once we have found an active path, we know that we cannot guarantee the independence by just looking at the graph structure. We're again asked about U and V, and now Z is observed. Here's the first path. This path consists of one triple, a V structure. The middle node is unobserved. Its descendants are all unobserved, so this is an inactive V structure, making the entire path inactive. Let's look at the other path, UWYXV. The first triple along the path, UWY, is an active triple. It's a causal chain with the middle node unobserved. The second triple is a V structure. The middle node is unobserved, so we have, and it has no descendants, so we have an inactive triple. This makes the entire path inactive. So we have two paths, both paths are inactive, so we're guaranteed that the independence is true. Okay, we're asked about two different variables here, W and X. There are two paths connecting W and X. Let's first look at the top path here. This path, WVX, consists of just one triple. This one triple is a common cause with the middle node unobserved. This means this triple is a active triple. It's the only triple along the path, which means the entire path is active. Once we find an active path, we know that just based on the graph structure, we cannot guarantee that the independence is true. We're now asked about x and t, and we have evidence variable v. There are two paths connecting x and t. There's xvt and there is xywvt. Let's first look at xvt. xvt is a path that consists of just one triple. This one triple is a common cause triple with the middle node observed. This means that this triple is a inactive triple. Once we find an inactive triple along a path, the entire path is inactive. So the first path is inactive. Along the second path, we see that we have a V structure here, x, y, w. This V structure has the middle node unobserved, no descendants, so no observed descendants. This V structure is inactive, which means the entire path is inactive. Both paths connecting x and t are inactive. That means we're guaranteed that x and t are conditionally independent given v. Now we're asked about x and w given u. Well, here's one path connecting x and w. Here's another path connecting x and w. The top path consists of a single triple. This single triple, wvx, is a common cause. This common cause has the middle node v unobserved, so it's an active triple. The path consists of just one triple. The triple is active, so the entire path is active. Once we find an active path, we know we're done with this type of exercise. Then we know that the independence cannot be guaranteed. Now we're asked about y and z. No evidence. Here's the first path connecting y and z, and here's the second path connecting y and z. Let's look at this first path first. This path consists of the triples yxv, xvt, and vtz. yxv is a causal chain with the middle node unobserved, so active. Means we keep going along this path. The next triple, xvt, is a common cause, the middle node unobserved, so triple is active, means we keep checking along this path. Now the last triple, vtz, this triple is a causal chain, the middle node t, unobserved, so also active. So we found that all triples along this path are active, which means we have an active path. Means we're done, we don't have to check any other paths anymore. Once we find an active path, we know that we cannot guarantee the independence. We're asked whether y and z are conditionally independent given t. There are two paths connecting y and z. We see that both of these paths have this triple, vtz. This triple vtz is a causal chain with the middle node observed. This triple is inactive. Both of these paths have this inactive triple, which means both of these paths are inactive. These are the only paths connecting y and z, so all paths connecting y and z are inactive, which means we can guarantee the conditional independence of y and z given t. We're again asked about y and z, and now we have an observation variable that's x. Two paths connecting y and z. Okay, well, let's start with the path yxvtz. For the path yxvtz, the first triple is yxv. This triple is a causal chain with the middle node observed. Means this triple is inactive, means the entire path is inactive. Means we move on to checking other paths. There's one other path, that's one we're going to check, yvtz. This path consists of a triple ywv, which is a causal chain with the middle node unobserved, so this triple is active. Then there's a triple wvt, which is a common cause with the middle node unobserved, so also active. And then there is VTZ, which is again a causal chain, and again the middle node is unobserved, which means it's active. We have 3 triples along the path. All 3 triples are active. That means the entire path is active. We found an active path connecting Y and Z. That means we're done. We cannot guarantee the conditional independence of Y and Z given X. I asked about Y and Z again, and now V is observed. Okay, let's start with the path Y, X, V, T, Z. There are 3 triples along the path. I'm going to start with this triple here, the XVT triple. That triple is a common cause. That triple has the middle node observed. This means the common cause triple here is inactive. Once one triple along a path is inactive, the entire path is inactive. So it's kind of nice that we started by checking a triple that's inactive, because that means we can stop checking triples along this path. We know the entire path here is inactive. Once we find the inactive path, that doesn't mean we're done. We need to keep checking other paths. There's just one other path here, Y, W, V, T, Z. Okay. I'm going to first check WVT of all triples along this second path. This path is a common cause with the cause V observed, so it's an inactive triple. This means the entire path is inactive. This means both paths connecting Y and Z are inactive, so we can guarantee Y is independent of Z given V. We're asked about W and Z, where V is observed. Okay, let's see. There is this path here, WVTZ. 2 triples along the path. I'm going to first check this triple here, WVT. That's a common cause with the middle node observed, so that's an inactive triple. An inactive triple along the path means the entire path is inactive, so we're done checking the WVTZ path. It's an inactive path. Here's another path, WYXVTZ. I'm going to again start with the common cause triple here. That is part of the path, the XVT triple. The middle node in the common cause observed, so the triple is inactive. Once we find an inactive triple along a path, the path is inactive. We check both paths are inactive, so the independence is guaranteed to be true. We're asked about U and Z with no evidence. U, Z, no evidence. There's this path here. Then there is this path here. Okay, let's start with the UWVTZ path. The first triple is a V structure, UWV. This V structure has the middle node unobserved. Its descendants, there's just one descendant, Y, is unobserved. This means we have a inactive triple. An inactive triple makes the entire path inactive. So we have verified that the first path is an inactive path. Let's verify the second path now. Well, the first triple I'm going to check along that path is the WYX triple. That's a V structure. The middle node is unobserved. None of its descendants are observed, so this V structure is inactive, making the entire path inactive. So both paths are inactive, so we can guarantee the independence is true. Our last example, we're looking at U and Z and observing Y. Let's first consider the path UVTZ. This path consists of the triple UWV, the triple WVT, and VTZ. Let's first check UWV. This triple is a V structure. The middle node in the V structure is unobserved. Let's look at its descendants. There's just one descendant, Y. This descendant is observed, so the V structure is active. When we find an active triple along a path, we need to keep checking. So we move on to the next triple along the path, which is WVT. This is a common cause with the middle node unobserved. Common cause, middle node unobserved means active. And then the last triple here, VTZ, is a causal chain, middle node unobserved, which also means active. All three triples along the path are active. This means the entire path is active. No need to check any other paths. We found an active path. That means we cannot guarantee that the independence is true just based on the graph structure. That's it for our review lecture on deseparation.